Bismillahirrahmanirrahim. Assalamu alaikum students. This is week number 12 of the course Software Requirements Engineering, and today's topic is the class diagram. So before starting today's lecture, let us see the previous lecture contents. In the previous lecture, we focused on software requirement specification with the detailed content. Now we will focus the today's lecture's contents. In today's lecture, we will learn that what is a class, what is a class diagram, what are the essential elements of a UML class diagram, the class name, attributes and relationships, what is aggregation versus composition, and what are the abstract classes. We will also see the examples of some UML class diagrams. Now, first of all, we will see that what is a class diagram. A class diagrams are basically one of the most useful types of diagrams in UML, as they clearly map out the structure of a particular system by modeling its classes, attributes, operations, and relationships between objects. Using our UML diagramming softwares, we can use the class diagram. There are a number of UML diagramming softwares like the Visio and Rational Rows, one of them. So basically, it is the most important and useful diagram which is used to map the structure of a system by modeling its three major components: the classes, the attributes, and the operations, and also the relationships between objects. So we can say, using the class diagram, we can model the structure of any system by modeling its classes, attributes, operations, and the relationships between different objects. Now we will see what are the essential elements of a UML class diagram. The essential elements of a UML class diagrams are: number 1, the class name; number 2, the attributes; and number 3, the operations. Before moving towards the essential elements of a UML diagram, which is called the class diagram, is basically represented by a rectangle with 3 partitions. The first partition is basically contains the name of the class. The second partition contains the specific attributes of that particular class, and the third partition contains the operation of that specific class. So next we will see the basic structure to model a class. First, we need to mention the name of the class, and the name of the class is basically presented in the first partition of the class. In the second partition, we will represent the attributes, and the third partition is related to the set of operations performed by that specific class. So, as you all can see, a class diagram is represented by this particular rectangle. So, following rules must be taken care of while representing the class. We should adopt some set of rules in order to represent a class. First, a class name should always start with a capital letter. It is important to represent the name of the class with a capital letter. A class name should always be in the center of the first compartment. Remember, the name of the class should always start with a capital letter and it should be in the center of the first compartment of that particular class structure. So, a class name should always be written in bold format. So next we have the basic components of a class diagram. The standard class diagram is composed of 3 sections as we have mentioned earlier. The upper section, the middle section, and the bottom section. The upper section contains the name of the class. So always remember, in order to present a class, you need to mention the name of the class in the upper section of that particular rectangle. This section is always required whether you're talking about the classifier or an object. Whether you're talking about a classifier or whether you're talking about an object, you must need to define this particular section. The middle section contains the attributes of the classes. Use this section to describe the qualities of a class. This is only required when describing a specific instance of a class. So, in order to describe the qualities of the class, we need certain set of attributes. So, this is only required when describing a specific instance of a class. The next we have the bottom section, and the bottom section includes the class operations, or we can say the methods. Displayed in a list format, each operation takes up its own line. The set of operations basically describes how a class interacts with the data. Suppose we have a class by the name of animals. So we will mention the name of the class with a capital alphabet, starting capital alphabet, and the name should be in the center of this particular compartment. Then here we will have the attributes, and the attributes are basically the significant piece of data containing the values that describes each instance of that class. Every class has a number of instances. Like the animal class contains a lot of instances like the lion, the tiger, the monkey, the dog, the cat. They are basically different instances of this particular class, which is called animal. In order to differentiate the different instances of a class, we need to define the set of attributes, which contains the particular values to describe each instance of this particular class. So, in order to represent a class, we need this particular rectangle with the 3 set of partitions. In first partition, we will represent the name of the class. In the second partition, we will represent the attributes of this particular class, and in the third partition, we will represent the basic methods of this particular class. The class name, the set of attributes, and the set of operations or methods will be described under these sections of a class. It is important to follow the given sequence in order to design a particular class. So remember, we always write the name of the class in the first compartment, then sequence-wise we will mention the set of attributes in the second compartment, and third we will have the set of operations or methods which will be performed by the specific instances of this particular class.